will now continue with the next speaker, who is Margot Pouleur from the Citadel Hospital, University Department of Neurology in Liège, Belgium, who will speak about a new digital measure to meaningfully assess daily life ambulatory function of people with multiple sclerosis. Please.
Thank you. Hello, everybody. I'm very happy to be there today to share with you our preliminary result on the use of digital outcome in multiple sclerosis. As we are a large group of authors, we have a few disclosures. So I won't tell you all the potential issue you can face with EDSS. EDSS is a great outcome that has been validated over years, but it remains a point assessment, unable to capture the fluctuation in daily living of our patient. More importantly, it relies on a rater and sometimes on what the patient reports, and it could induce some subjectivity. So could digital outcome provide an objective continuous assessment for our patient? The answer is yes, and we know it's possible because we have recently gathered the approval of the EMA for the use of a digital outcome in clinical trial in Duchenne muscular dystrophy. Obviously, multiple sclerosis and Duchenne are not the same, and that's why we had to get back from the start in MS. So when it comes to digital outcome, and in fact any outcome, the first thing you need is a concept of interest. In MS, we've known from past research that walking speed is one, and so we decided to focus on that. Then you need to show that what you are measuring is relevant in the condition you want to assess, and that's what we call clinical validation. So I will tell you in a few minutes about the technology we use and about the outcome we identified. But the first thing you need to know about this outcome is, I'm sorry for the topic of the session, but it's definitely not a problem. It's an objective assessment of gait in MS. So the ECTRIMS study was designed to identify and validate an outcome to assess gait in MS. So we want to know if we can identify an outcome that could check all the boxes on the left. And mainly the last one, the ability to get to detect change, as it is maybe the most challenging part. So it is a longitudinal multi-site 1-year study with 2 evaluations. We have enrolled 78 patients, EDSS ranging from 0 to 5.5, mean 3, so let's say mild to moderate MS. And after each clinical evaluation, we assess patients with a wearable device in daily living. This device is able to identify and measure each stride of the patient, and that's exactly the kind of signal you get from a walking patient. Each trajectory is a stride, and we can measure it, and then we can have a look at the density, at the distribution of stride speed. And then we choose to focus only on the 5% fastest walking stride. Why walking and not running? It's because in adult running, it's too much social and weather dependent. So the data I'm going to show today are really focusing on the walking speed 95 centile, which is the top walking performance of a patient in real life. As you can see, adherence was excellent. We consider that on a 1-month recording period, 50 hours is sufficient to compute data, and more than 180 hours is excellent. 97% of recording period were sufficient, and among them 88% were excellent. The 95 centile of walking speed show an excellent reliability with an ECC of 0.98, which means that when you compare 3 consecutive 1-month period, the result you get is nearly the same. Then we wanted to see if we can differentiate between levels of disability, and as you can see, we had a really significant difference between 3 adjacent subgroups. We had a good correlation of around 0.7 between the 95th centile walking speed and DSS, as well as the time 25 foot walk. And sorry, I share with you the data about the baseline, but what about longitudinal data? Are we able to show a decline in progressive patient at 1 year, and what is happening in a relapsing remitting patient? So as you can see, as expected, we have a very significant decline at 1 year in the progressive population, despite the small number of patients. And in the relapsing remitting patient, the evolution was more heterogeneous, but interestingly, as a group, we have a small but significant decline at 1 year. So, of course, it's a small subset of 37 patients, and it needs to be confirmed on a larger cohort. With the DSS, we could only see a decline in the progressive population, as expected, and we didn't see any decline with the time 25 foot walk. So the take-home message of this talk is that it's completely feasible to assess MS patient with a wearable device with a good adherence. The 95 centile of walking speed is very reliable, as an excellent construct validity, and more importantly, it's able to detect change at 1 year in progressive patient, but also in relapsing remitting patient. Of course, this last conclusion needs to be confirmed as it is a bold one, and that's why we are acquiring data on another data set, and we have planned for a 2-year extension for this study with more frequent evaluation every 6 months. So I would like to thank all the persons that have made this study possible, investigator, patients, and funder, and thank you all for your attention.